Hi everybody. Hi everyone. My name is Sara Verkiyani, and today I will present my capstone project titled "Design of an Agentic AI-based travel planning system for personalized and cost-efficient itinerary generation." Before I begin, I would like to share a personal story. I have always loved traveling, exploring new places, and trying to experience the exciting part of and trying new experience. The exciting part of travel is the adventure itself. The less exciting part is spending hours comparing flights, hotels, transportation option, activities, prices, maps, weather forecast, and dozens of browser tabs. Sometimes planning the trip feels more exhausting than the trip itself. So I start wondering, what if I had a personal travel assistant that never gets tired, remember all my preferences, understand my budget, check all the information for me, and help plan the entire trip. Unfortunately, I could not hire a personal travel agent as a graduate student, so I decided to build one instead. This project explores how agentic AI, large language model, and intelligence multi-agent system can work together to create a personalized travel planning assistant capable of generating adaptive and cost-efficient travel itineraries. Current travel planning system can recommend hotels, flight, or activities, and recent AI-powered systems have improved personalization through conversational interface. However, most existing
Sarah,
solutions.
Sarah, let me interrupt you. Are you changing the slide just so we can see the cover page?
Oh,
Okay, okay. Now you are moving. Got it.
yes, I'm just explaining the motivation. Okay. Current travel, most existing solutions focus on individual tasks and lack the ability to perform, coordinate multi-step planning. They generally cannot reason across transportation, accommodation, budget, weather condition, and activity scheduling at the same time. Um, as a result, users still need to manually compare options and make planning. This creates the need for a more intelligent and autonomous planning solution. Um, okay. Uh, I guess. Um, to address the limitation, my project proposed an agentic AI-based travel planning system that combines large language models, intelligent agent, and orchestration mechanism. Instead of providing isolated recommendation, the purpose system decomposes travel planning into multiple tasks, coordinate a specialized agent, and generate a personalized and adaptive itinerary based on user preference, budget, constraint, and travel goals. Um, the goal is to move from simple recommendation system toward intelligent and autonomous planning. Um, the travel planning can be complex and time-consuming process. Um, Travel planning is naturally a multi-step problem. User must search for transportation, accommodation, destination, activities, um, while considering constraints such as a budget and time limitation. Existing recommendation systems provide useful suggestions, but they generally lack reasoning and coordinating across different planning and tasks. Um, the background, several technology from the foundation of this project. First, traditional travel planning system rely heavily on predefined rules and static recommendation. Second, large language model enable conversational interaction and contextual understanding. Third, recommendation system use machine learning to generate personalized suggestion. And finally, agentic AI introduce goal-oriented reasoning, planning, and execute capability. By combine these technologies, we can move beyond simple recommendation and build a system capable of intelligent decision making. This is my purpose. The related work, existing research has
Okay,
contributed.
Sarah, 10 minutes left. Go ahead.
Okay. Existing research has contributed significant to travel planning system. Studies using large language model improve personalizing and conversational interaction. Deep learning approach improve prediction and itinerary optimization. Distributed system improve scalability, while blockchain and based approach improve trust and security. The synthetic matrix compare four major studies with my proposed approach. The the comparison evaluation several criteria including personalization, adaptability, autonomous decision making, scalability, and things like that. My purpose approach combine the strength of these studies by integration large language model, intelligent agents, orchestration mechanism, and recommendation system into a single unified architecture. This allows the system to support adaptive and coordinate travel planning. Maybe we can skip this one for save the time and we can back. And because I like the approach. Um, the purpose begins when a user provides travel preference through a conversational interface. A large language model analyzes the request and extract travel requirement. I can show you some example from my project. Um, can you see the browser? Can you see this web page?
Yes.
This okay. Uh,
Yeah,
um,
yeah.
this is the when I say the user preference, it means like that. When they hit the new trip and write their preference, a large language model analyzes the request and extracts travel requirements. The planning task is then decomposed into multiple subtasks. This is my favorite part. A specialized intelligent agents work on a specific tasks such as transportation, accommodation, activities, and budget management. As you can see here, there are several different agents. Okay. The orchestration layer combines the output and generates an optimized itinerary. The system can also dynamically adapt when user preference change. The key difference between my approach and traditional chatbot is task decomposition. Instead of asking one model to solve the entire travel planning problem, the system breaks the problem into similar specialized tasks and assign them to dedicated agents. This allows each agent to focus on a specific reasoning while the orchestration coordinate the overall workflow. Um, and maybe we can have more explain if we want, but let me just for now go to another one. This the UI design. I just try to make everything very simple, as you can see here. Sorry, just a moment. And just show everything very simple. Um, then we can go to the solution architecture. Design. Okay. Solution architecture. The architecture consists of 5 layers. The user interaction layer handles communication with the user. The orchestration layer coordinate workflow, execute, and agent communication. The intelligent layer contains specialized agents, the recommendation and optimizing layer, evaluate option, and generate recommendation. Finally, the external data source layer connect to travel APIs, weather service, and mapping the system. The modular architecture improved scalability, flexibility, and intelligent decision making. Um, and Workflow design. The workflow illustrated how the system processes travel requests. The user submit preference, the orchestration layer decompose the request into multiple tasks, a specialized agent process their assigned task independently, and the orchestration layer then decompose the result, resolve conflict, and generate an optimized itinerary. The workflow support continuous refinement and adaptive planning. And implementation. And this prototype was implemented as a web-based travel planning system. The backend used Python and Fast API. Langchain is used to support orchestration, reasoning, and memory management. I use memory management, for example, if I want, it's a kind of I'm showing my demo too. When I hit the new trip and select my preference, then for example, now I'm going to the chat assignment. I have my preference here. I use a long term for memory management. So if I start, for example, asking questions, um, here, for example, okay, sorry. I have everything. The architecture includes multiple intelligent agents coordinated by orchestration agent, um, based on my preference that I save it in my memory. It gives me offers, and I use OpenAPI for implement this part, and I still have uh, the memory. For example, I ask about the museum and things in day two, and it gives me a plan, and I can ask there, can you make it cheaper, and still continue and give me some result. Uh, and if I have agenting trace here, in that one show me about the uh, different agents. When I ask a question, the process, how it work, and I still have implemented, demonstrate um, how agentic AI concept can be applied in a particular travel planning, and have the decomposite.
2 minutes left.
Okay, so data collection, and from data collection, the system collect both structured and unstructured data. Um, Provide information include destination preference, budget constraint, and the other sides I have data. So I have data like budget and things like that. The other side I have some unstructured like API. In data analysis, evaluate the efficiency and purpose system. Several metrics are considered, including recommendation accuracy, personalization, quality, cost optimization, and workflow efficiently. The analyst also examine how well the intelligent agent collaborate and how efficient the system adapt to changes the user requirement. The finding part, the evaluation demonstration that the purpose system improve personalization, recommendation, quality, and itinerary coordinate compared to traditional approach. The multi-agent architecture successfully coordinate a specialized planning task, and while maintaining consistency across the itinerary. And in addition, adaptive update improve flexibility and response user change. The conclusion, this project proposed an agentic AI-based travel planning system for personalized, cost-efficient itinerary generation. The system combines large language models, intelligent agents, orchestration mechanisms, and recommendation techniques. The result suggests that this architecture can improve personalization, adaptability, and intelligent travel coordination. The project demonstrates how agentic AI can support complex real-world planning tasks and provide a foundation for future traveling planning system. This is my GitHub reference and
Right.
future work. My time is end.
Yeah. Your time is up. Now is time for Q&A. If there is not a lot of questions, then perhaps you can go a little bit through the future work.
Okay.
Um, but for now, does anybody have any questions for Sarah?
Yes, I have a question. How did you evaluate your system?
Excuse me. Evaluate
How,
which
yeah,
step?
yeah. How did you evaluate your system? Yeah,
My system.
yeah.
Uh, I
So go to the collected data. Then
my collective data is list collected.
so you design it. Then why do you say your system is good? Yeah,
Excuse me. My system is
yeah. So always you have to assess your application, right? How did you assess? Yeah, data collections. Then
uh, uh,
quantitative data, cost, distance, rating. So how,
uh,
how did you evaluate your system? Yeah.
my system. My data mm, is not a kind of like data that we can process data. Is most like APIs. For example, weather APIs. When I request for travel to San Francisco to that specific date, I can use the for example, weather API, um, hotel flying API is a kind of my data that I use, and I have some
Yeah.
quantitative data to like cost, distance, rating, travel duration, and things like that.
Okay. Okay. Got it. Yeah. Okay. Harrison, I'm done.
Okay, thank you, Sam, for the questions. Does anybody else have anything to ask Sarah? Okay, I guess I just only have one question. I'm a little bit curious about how you're gonna expand your project. You kind of haven't gone through